Hello, good morning, little scientists. Welcome back to another science meeting. It's a pleasure to be back with you. Today, we're going to continue working on our energy transfer module, specifically on our lesson 4 titled Heat. We're trying to answer the essential question, what is heat? Today is Wednesday, April 22, and our title, or actually our lesson for today is titled Producing Thermal Energy. In our last meeting, we had the opportunity to take a look at three different ways in which thermal energy can be transferred. Today, in our teaching point, we're going to be explaining how using LED light bulbs helps save energy. I actually encourage you now to pause the video and get to copy the date, lesson, and teaching point just before we jump in to our question of the day. In our question of the day, we got the following statement. Is the energy that comes in the form of wave or particles? Right here we have four different concepts that we worked out in our last session. Energy transfer, conduction, radiation, and convection. I encourage you once again to pause the video and try to see if your answer matches the correct one in this case. Anyway, I share with you right here. So the right one is radiation. So radiation is the emission or transmission of energy in the form of wave. These waves are really special because they don't need a space, they don't need actually a medium to travel. They can actually travel through space without a need of having a material medium. So an example of radiation is that energy that is coming all the way from the sun to the earth. We can actually see this wave, well, we can actually feel the warmth of this radiation coming to us. Going back to our teaching point, we must remember that we're trying to explain how using LED light bulbs helps save energy. How is that? Alright? So like all energy, thermal energy cannot be created or destroyed. And that takes us back to the law of conservation of energy that we discussed at the beginning of the school year. It states that energy can neither be created nor destroyed. It can only be converted from one form of energy to another. That means that this thermal energy that we have can only be expressed in other forms, but it can actually be destroyed. Alright, it can be released as energy changes occur. Now, if you rub your hands together very fast, you can feel them get warmer. Friction between your hands changes the energy of motion into thermal energy. So right there we have an energy conversion situation. We have this motion from rubbing our hands together becoming thermal energy the more we try. So there was a concept that we just mentioned right there, which is friction. This is another concept that we worked early on this year. And as we might remember, friction is the force that holds back the movement of a sliding object. That means that the two objects should be touching each other for you to have friction. As you can see in the picture, we have this guy pulling to the left and the friction exerting a force to the right. Every time that you have friction, you will have friction in an opposite direction to the movement that you're applying, to the motion that you're applying. Why is that? Because friction is always holding back the movement. So that means that it will always go against the motion. So right here we have a match box actually. So the friction between the match head and the surface produces enough heat to light the match. So when we rub the match against the butts, we can generate enough friction that actually hits the head of the match, and actually this chemical energy that is held in the mat, catches fires, and then we have energy transfer right there. Sometimes the heat produced by friction can cause problems. When the parts of a machine rub together, friction between the parts produces thermal energy. The machine has less energy to do work because the machine has changed some of its energy to thermal energy. Melting and burning are other ways to produce thermal energy. Some of the energy in a chemical reaction may be given off as heat. In a campfire, chemical energy stored in wood is released as heat when logs burn. Alright? Taking a look at these two light bulbs. Light bulbs also release heat as they convert energy into light. Incandescent light bulbs get very hot because most of the light, or actually most of the energy, is transformed into heat, which makes them much more inefficient compared to LED lamps that we have on the right. LED lamps waste very little energy in the form of heat. They can produce the same amount of brightness as an incandescent light bulb, but with less energy. LEDs can even last up to 20 years. Oh my god, that's a lot of time for a light bulb. As we can see right here, the benefits, when we compare this, the benefits, mostly of them go to the LED. The LEDs resist actually can last longer, as I mentioned before, 10 years, actually 20 years, my bad. And also, the energy that is lost in form of heat is way less than the one is right here. This model was actually one of the first ones that were tried. So as time evolved, we had the opportunity to work on the technology of this light bulb and actually get to this modern one right here. So basically the greatest advantage of this, or the great um, opportunity to save energy on LED light bulbs, is actually on the way they behave in front of electricity. As we said before, electricity is a type of kinetic energy because the particles that are inside or that are involved in this energy transfer are moving. So that means that we're going to have some heat as these particles move. Now, in this incandescent light bulb, then the heat that is produced is way too more compared to the one that is produced on the LED. So we have less energy loss on the LED because we don't have that much heat emission that we have on the other one. If we take a look at the pie charts that we have at the bottom, we may see that on the incandescent light bulb, we have only 2% of light and 98% of the energy that is being consumed is in the form, or actually wasted in the form of heat. So basically we have a fire just right there. On the other hand, we have the LED. From the energy that is being consumed, we have 91% of that energy being produced as light. That's basically what we want from a light bulb. And only 90% as heat. So very little energy is lost on this process. So what are we trying in our independent work for today? On page 71, you have only one question. So you're going to answer this question right there, explaining how would you use LED light bulbs to help save energy. If you can actually research more on this online, that would be better, so you can get deeper insights than the ones that I present. So that will do it for today, guys. I hope that you have enjoyed this lesson. If you have any questions and doubts on asking me. So we will until another time. So bye bye.